Hello everyone, let's solve this question. In this question, we are given a 3 cross 3 matrix, total 9 cells. Then total number of stones available in this whole grid will be 9. Our task is to try to find the minimum number of moves through which we can place one stone in each cell. Okay, then we can move from one cell to adjacent cell, like which are sharing the borders only. And okay, let's try this, like solve this question. Constants are pretty low. Okay, first I will explain the question again. Okay, let's say we are having this 3 cross 3 matrix. If a cell is containing some, let's say in this cell we are having 3, then somewhere 1, okay, 5 gone, 1, 4, 7, 1, 1. Okay, these two are 0. So we need to move the stones from here to here and here. We need to find the minimum number of moves. Let's say from here, then we have, let's say here we are not having one more than one, then we can move here. Every cell has to contain one, so there is no point of moving this thing to here and this thing to then like reverse. We have to find the minimum possible number of moves. So okay, how I will approach this question? I'll first find like two vectors of pairs. I will try to store. Okay, one vector of like pair int and okay, I need to store vectors of this thing, and one will be 0, one will be non-zero. Non-zero means where I am having more than like stones more than one. Zeros where like we have to add some stones. At least there will be two categories, like one having more than one having less than 0, like one having 0. Those who are having number of ones, no need to bother about them because they are already balanced. We need to move the like stones from which are having more than ones to number of zeros. As the constants are pretty low, I will try to like I will try to optimize, like search for everything, every possible combination and give the best optimal result. In 0, I will store the like indices, like pairs in which I am having 0, 0. Let's say for this I am having 0 at here. Then coordinate of this thing will be like 0th row, first row and second column. Then I will be storing 1, 2. Then another I have to store 2, 2. This thing will be in my 0 vector, and for this non-zero vector I will be storing this thing 2 times, like how many times it's like stones appear in that box, more than one, like number of stones appearing more than one, that many times I will store that index as a non-zero. Then let's say in this one it means like 2, 1, I'm having it's at 2 times. I'll try to map these things, like for each combination I will try to solve. Okay, this is here, like this is like these two are having, then these two pairs will be like coming same here. Let's say if it is here is 2 comma, not 2, 2 comma, no, this is 2 comma 0, I guess, sorry. 2 comma 0. Let's say it is not comma 2 comma 1, then this will be one pair, then other one pair will be this one is one pair, and okay, let me draw another pair. This is one pair, there will be one cost associated with this thing, then another pair will be this. Like we can see from like two different combinations, and two have different combinations, we can make multiple combinations. We'll try to optimize, like try to get the minimum result out of all these combinations. What I like, how I will proceed this problem. Okay, let's say okay, in 0 I am having all the indices as a pair format, and in non-zero I am having all the indices which are having more than one, and how many number of times they are appearing, that time we are here appearing. Okay, first thing, how many times, like what is the maximum value that Z can go? We are having a 3 cross 3 matrix, means total 9 cells. at least one cell will be there who is not able to have any zero elements. Like let's say here everywhere is zero, then this element will be containing nine stones. At least nine stones are there in question that is given. Then in the cell, there may be in some unbalanced form. We need to try to find the balance. Then all the zeros will go here, like all the possible combination, and this thing is more than like one, it's more than appearing 8 times, then this thing will go here. Okay, for 0 I can have at max 8 value. Okay, I'll try to store them as in a DP, like then I can calculate, like let's say for zeros having here is a pair, here is a B and here is C, then I will try to like how many number of here number of zeros appearing, that many times number of zeros non-zeros can appear, because that will be a balance between the total number of stone and total number of cell is 9, both are constant. So I'll try to find the balance here, try to find balance here, and then I'll try to go for the combination which is having minimum number of combination, minimum number of, then I'll be recurring for every possible combination, and I will be backtracking, and I will store those values in a DP format. Okay, my DP will be in 2D DP. Then first I will store like this thing non-zero, then this thing max can go to 8. This here I will check whether from non-zero, like for every zero I will check how many non-zeros I've already attached to zero. If those are not attached, then I will attach with someone else, like this thing, like in non-zero these cells are not previously taken by zeros. Let's say I have already, for non-zero, like for zero, let's say I have already three three zero pairs, like I have already compared with some non-zero. Then now I will, for this index I will check whether those are not already assigned to any zero cell, that I will try to like assign, and I will check the minimum cost where I am getting. That will be my result. Okay, this thing will be better understood when I will code this part. Okay, let's start this code part. Okay, for to be clear, here I will be passing one integer for which I will be setting, like at max it can go to 8. So I will be setting those the numbers that bit, so that it can max like 2 to the power 8 can be my max result. Then 2 to the power 56, that is 2 to the power 8, then that is the number. Okay, when I will code this part, this will be more understandable. Okay, first I need to get how many numbers of zeros are present. Let's say I will define that int cntz equal to 0. Now I have to find how many zeros are present. Okay, now my zeros are this many zeros. Then I have to store the vector of pairs, like wherever zero appearing, that is z, and wherever non-zeros appearing, that is non-z. Okay, in this I can edit. Okay, I need to insert those non-zeros. How many times? The number of times there the stone is more than one. If it is one, then no need to insert. So GD ij minus 1 till I will go plus k. That many times I have to. Okay, I think this thing is created now. Then okay, now I need to create a DP where I will store the results. Okay. Now I will return the recursion, but like return the value that I'm getting from the. Okay, what I will pass 0 0. No, I will first I'll write the recursion function, then I will calculate how I need go. And first thing I need to count, like have a count of what index I'm calculating. This is idx underscore z, comma, and mask. If idx z means like how many number of z, like 0, I have already solved. If I have already solved everything, equal to cnt z, return 0. Okay, that means I already solved everything of this z. Okay, I can use like cnt equal to z size. Okay, that will be how many times z I am pushing anything to z. That is my cnt dot z, cnt z. Okay, else all okay. If I already having in dp, then no, I'll code that part later. Okay, I am iterating over this thing. If iterating over this thing means how many non-zeros are available now. Like right now I'm at idx 0. How many non-zeros available that are not masked, that thing I have to check and further go. If, then go idx underscore z plus 1 comma mask and jar. I'm just setting those bits like what I okay, this thing will result like return some result x equal to this thing. I need to have a cost. Initially my cost is this much. Okay, I will store that in cost. Okay, what I did here, like let's say we are at idx 0. till idx 0 to the end, what I am getting cost, that will, this thing will result, like for every possible combination I am here checking. Let's say these many non-zeros available, then like if it is available, that I'm masking, like not masking, like it will be unmasked. If that is not masked, then I will calculate this non-zero and this zero, then I will assign. Okay, first then I have to count the cost of assigning this thing. Okay, cost function. Okay, distance. Okay, this thing means like from moving A to B, what is my cost? That cost I have to add because right now I'm at IDX Z. This index I have to set. I am setting with all like what are available in NZ. Mask represents like if the bit in mask is set, that means that corresponding index in NZ is already taken by someone else. If that is not set, that is equal to 0, then I'm setting that thing with this thing. Then I have to add that to X also. IDX 0, then my I will be the index of non-zero. Okay, I think that's it. That is here I am just masking and forwarding. That will not change my mask here. So I have to return cost. Okay, for record I need to store this thing as a DP so that my computation overhead does not exceed. Mask equals to this thing. Okay. Okay, this thing, if this is already computed, not equals to -1, return this thing. I think that's it. That's wrong. Oh, here what need was okay. Only those like first zeros. Nobody like zero element I am to for zero element I am to set. Like till now mask is 0 means nobody is set. Yeah, yeah, that's correct. It's a really nice question. Thanks for listening.